So hello everyone, in this video we will be solving another LeetCode problem, and the problem name is minimum ASCII delete sum for two strings. So given two strings S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. So what the question is saying that you are given two strings, let's say S1 is C and S2 is eat. Now you need to delete some characters, and after deleting, both of the strings should become equal, and you need to delete such that whatever deletions you make, their ASCII values, their sum of their ASCII values should be as minimum as possible. So this is the first example in which S1 and S2 are given as follows. So if you delete S from S1 and T from S2, you get final string S1 as EA and S2 as EA. So both the strings are equal, so you deleted two characters S and T. S has the ASCII value 115 and T has the ASCII value 116. So if you just add this, you will get answer as 231. So that's why the output here is 231. But how will we say that okay, this character to delete or this character to keep? So let us understand with the help of this example only how we will try to build the solution. So this is the example one which I am just drawing here. So example 1 has S1 equal to S E A and S2 as E A T. Now initially our I pointer, which is nothing but pointing to the S1 strings character, and J pointer, which would be pointing to S2 strings character, would be initially pointing to the first character of both the strings. Now you will think here at this point like which character to delete. Either I should delete this S character or I should delete this E character. You can't decide because you need to take at least one decision, right? Whether to delete the S character or E character. Now if you delete S character, you might end up saying okay, now here our I will be pointing to E, and here also our J is pointing to E. So these characters are matching. So yes, our decision of deleting S was correct because now our characters are start to matching each other. But what if you deleted E? If you would have deleted E, your I would be pointing to this S and your J would be pointing to this A. So now you are not matching any E characters or similar characters. Now you are again comparing two characters which are not equal. So you will never get your final answer as EA because E is already deleted, and you will never have EA kind of sequence or again in the future. So which choice to make? In this case we can say that okay, we will delete the S character. But how will you decide every time which character to delete, which character to keep? So whenever you have these kind of situations where you don't know which thing to do, either you should pick this thing or do not pick this thing. Either you should delete this thing or you should not delete this thing. Where you can't decide a logical way, or you can't say that okay, if I do this I will get my minimum or maximum answer, or if I do not do this I will get the minimum or maximum answer. So in these kind of situation where you cannot decide what thing to do, a logical idea, what is the best idea to do? The best idea is try all combinations. So in this case we will first see okay, if I delete E and then move forward, what answer will I get? Again I will just move I will choose the another option. Another option is to delete the S character. Now I will again check what if I delete S character and then move forward with the string, what answer will I get? So you try out both the combinations, first by deleting E character, then by deleting S character. So you tried out all the possible combinations, and what you are doing in this trying all the possible combinations, you are simply doing recursion. But wait, the constraints are I think less than equal to 1000, so recursion won't work. But wait, if recursion don't work and constraints are still low within the 1000 range, we can just memoize this. So we will memoize this and we will solve this particular question using DP. Now another thing to notice is that how many states will be there in the DP, because we need to decide whether this will be 1D DP, whether this will be 2D DP, whether this will be a 3D DP. So states or so the dimensions of the DP depends on number of states. So number of states is what gives you dimensions of DP. So if there are 2 states, you will create 2D DP. If there are 3 states changing, you will create 3D DP. Now what all things here in this particular question are changing? In this question there are only 2 things changing. First is the I pointer in the S1 string, and second one is the J pointer in the S2 string, because we are not doing anything else. We are just moving forward with we are playing everything on the basis of I and J pointer. So in this question 2 things are changing, that is I and J character. So we'll be creating 2D DP of size n, m. So this was about the DP part. So let us see how actually we are going to solve this particular question using DP. So I'll just dry run this entire example once so that it is easier for you to visualize how the DP will work, and then we will try to write the code as well. So initially your I pointer will be here and J pointer will be here. Now in this case I know deleting S will give me the correct answer, so I will show you direct the solution path. I will not try out each and every combination, because in this case our main aim is to write the DP. So I'll just show you the solution path. So in this case first we will be deleting S. Now deleting S means what? Deleting S means we are not actually deleting the character, we are just moving forward with the I pointer. So if we are moving forward with the I pointer, now our S1 string starts from here and our S2 string starts from here. So now we are again comparing, are these both characters matching? Now why we deleted actually S character? Because obviously at this point our S and E were not matching, that's why we deleted this particular S character. But now we are at this particular position at E. Now we both the characters are E and E. Now think logically, in this particular case, will you delete this character or not? No, obviously, because this won't help you in any case, because deleting a character will only add something to your answer, not remove something from your answer. So whenever S1 of I is equal to S2 of J, simply do I plus 1 and J plus 1 in your recursion. So this is one step. So I plus 1 will take you here and J plus 1 will take you here. Now again both of these characters are matching, so okay, we will again not delete the characters A. So we will again move forward with our iteration. So now our I pointer is out of bound and our J pointer is at S2. Now just think, if the S1 string is completed, shouldn't you delete this T character? Because if S1 string is ended, that means whatever string is there in S1 is already matching with the string in the S2. So now still there are some characters remaining in the S2, so you should delete all of these characters. Similarly vice versa, what if your S2 string was getting out of bound? Let's say you have S2 string and here S1. Now let's say your S2 string got out of bound, your S2 is here, and still you have some characters left in the S1. So till now all the characters of S2 were matching with all the characters of S1 through the recursion part that we are getting till now, through the entire iterations that we have done till now. But now your S2 is out of bound, so you can say that whatever characters are there in S2 are matching with S1, but there are characters that are extra in the S1 part, so we will delete those extra characters. So similarly here in the S2 part we have this T character extra. So from here, in this case we have only one character, but what if there were more characters? So what we would do, from this J pointer till the end of this string we would delete all of these characters. Deleting simply means going forward with the J pointer and just adding whatever ASCII value is to our answer. So this is how we'll be solving this particular problem. So let me just show you how we'll be doing in this, like how will we write the DP part, just to give you an idea. Then we will also see the code. So the base case would be if our I reaches n, that is the size 1 string s1 dot size, as well as our j is also reached the end of the string. I am taking s1 size as n and s2 size as m. So you can follow with this way. So in this case, obviously both of the strings are ending at the same time, so we can simply return 0 from here because we don't need to delete anything from here now. But what if our I has reached the n? So if our I has reached the n, so we will declare one variable k which will be starting from j and it will be going up till m, and it will delete all the characters. Deleting all the character means taking sum of each and every character. And similarly, what if our j was getting out of bounds? So if our j was getting out of bounds, so we will do the same thing here. So we will run a loop which will be starting from I, because now we need to delete the characters from the s1 string. So we will be starting from I, from where the current iteration is, till the end. So till the end means where k is less than n and k plus plus. From this position we will delete all the characters. Deleting all the characters means simply adding their ASCII value to your answer. Now we need to do the DP transition states. Now you need to think what all transitions we can get. So simply there will be some DP memoization conditions here. I am not writing this here, I am just showing you the main part. So there will be one condition if s1 of I is equal to s2 of j. So this condition we have already seen. So in this question, in this scenario, what will happen? If both the characters are matching, we don't need to delete anything. Simply move forward with I and j. So I plus 1 and j plus 1 in this case. So whatever your function is, solve or whatever. But what if your characters are not matching? So in this case you will have two choices. So first choice will be, you will say okay, delete the ith character and keep the jth character, or you will have the choice delete the jth character and keep the ith character. So if you are deleting the ith character from the s1 string, so you are moving forward with the I pointer. If you are deleting jth character from the s2 string, so you are moving forward with the jth character. Also you need to add something to it. What addition you need to do? The I value that you deleted or the j value that you deleted, its ASCII value. So s1 of I plus recursion. Similarly here we will have s2 of j plus recursion. So this is how you'll be doing, and then obviously the memoization part and all of that. So this is how we will be transitioning the DP part. If you are deleting the ith character, simply take the sum of that particular ASCII value of that ith character and move forward with the recursion. So you'll do I plus 1 and j as it is. If you are deleting the jth character from the s2 string, take the jth character's ASCII value, add it to your current answer and move forward with the recursion. So go j plus 1 and keep I as it is. So this is how we will be solving with the help of DP. So let us see the code now. So this is the code. First I have declared two variables n and m. N is the size of s1 string and m is the size of s2 string. Then I have created the 2D DP of size n cross m, initialized everything to -1. Then I am calling this solve function to give me the minimum sum of the all the deleting characters of the ASCII values. So I am just calling this solve function to give me the answer. Now what is there in this solve function? First of all, we are keeping I and j pointer, I for the iteration on the s1 string and j for iterating on the s2 string. These n and m variables are the size, s string s1, string s2 and the DP. Now first comes the base case. If both of the characters are ending at, if both of the pointers are ending at the same time, that means before that all of the strings, all of the characters were matching, and now they are ending at the same time. So simply return 0. We don't need to delete anything now, because both the string ended here only at the same time, and before that everything was matching. So simply return 0 from here. But what if one of your iteration is completed and other is still left? So let's say s1 iteration is completed. So in this case, from j till the end of the string, that is m, you need to delete all the characters. So start your iteration from j in the s2 and go up till its ending. Ending means m. M is the size of the s2 string. So and just delete the characters. Deleting the characters means just take the sum of the ASCII values. So this is how you get the ASCII value, and in the end simply return the sum. Now what if it was the other way around? What if your second string was ended first and first string was still remaining? So simply go from I up till n, delete all the characters. So take a k variable, go start from I, go up till end, take the sum of all the variables that you need to delete. Not variables, the characters that you need to delete. And this is how you take the ASCII value, int of whatever character is that. In the end, return the sum. Now this is the simple memoization case. If you have already solved this sub problem, just return that sub problem. Now comes the transition part. If your s1 of I is equal to s2 of j, that means if your both the characters are matching, simply move one step forward in both the strings. So you do I plus 1 and j plus 1. But what if this is not the case? In this case, you can have two choices. Either you will delete the ith character or you will delete the jth character. And whatever gives you the minimum answer, so you will take that. So you'll take the minimum answer for both of the scenarios. For whatever scenario gives you the minimum answer, so you will take that. So first scenario is what? Delete the ith character from s1 string. So to delete the ith character, we will take the ASCII value of that. So s1 of I, and then you will solve for the further recursion steps. So in this case, you are deleting the ith character, so you will do I plus 1 and your j will remain as it is. What is the second scenario? Second scenario is deleting the jth character from s2 string. So if you are deleting the jth character, so you will take its ASCII value first, s2 of j, and solve for the recursion part for the further steps. That's how will you move forward? Your I will remain same and j will move one step forward. And then you are just simply storing it into your DP matrix. So this is how you will be solving this particular problem. So I hope you understand this problem. I tried my best to explain, and this problem is similar to the edit distance problem. So you can watch that video out. I have already attached a card right here in the beginning of the video, so you can just click on that and watch this edit distance problem as well. So yeah, I hope you understand this solution. Thank you for watching.